What is IPv6? Well, IPv6 is the current version of the Internet Protocol. You probably know IPv4 because you've been using it for 10 or more years, and IPv6 is just the next generation. IP is used for communication between machines in your local network and also on the Internet, and nearly all networks use IP nowadays. But why do we need it? Well, IPv4, the previous generation, was created in the 70s, and it was never meant to be for such a high number of devices on the Internet. As you probably heard, we don't have any IPv4 addresses left. They are just 32 bits, so theoretically we only have about 4 billion addresses. But in practice, there are some classes, I will talk about that later, that are not usable, which means we even have less addresses. And you know how many people we have? We don't even have one IP address per person on Earth. That's not enough. You maybe have 10 devices at least. So, IPv4 addresses are exhausted, but we need more addresses. In the beginning of the Internet, big blocks of public IPv4 space were allocated to large corporations like Microsoft or Google a bit later, but still they are receiving whole/8s, which is just too many. And we only have 221/8s available, and we cannot even use each one of them. So let's review classful IP addressing. In the beginning, we were using classful IP addressing from 81 to 1993. The addresses of IPv4 were separated into 5 classes, A, B, C, D, and E. The network mask was fixed per class and could not be changed, which meant you have these different classes available. In the past, if you had a network size of 256 or less, you could use a class C block, but if you had more devices, you would have to use a class B block, which is 65,000 addresses. And if you have even more than that, if you're, say, Microsoft or IBM at the time, you would say, no, that's not enough, we have more devices. So let's get a class A, which is 16 million addresses. And there is nothing in between, because classful IP addressing meant that there is no subnet mask like today. The subnet mask is fixed per IP address block. And then people realized, okay, we won't have enough addresses. So let's do something. Let's switch to classless IP addressing. We did this since 1993. So there are no fixed classes anymore, which means there is no class ABC. There is only a network mask and a network. And it's now called prefix. This is also called CIDR notation, classless interdomain routing, like 172.23.5/24. You have a network and you have a slash and then you have a mask. Let me show you an example of IPv4 classless addressing. This is the network masks. You can have everything from a /32, which is just one single address, to /0, which is the default route because there is not a single bit set for the network mask. Still, why do we need IPv6 if we have classless addressing? Well, since the early 90s, it was clear that IP addresses will not be enough. In 1993, we changed from classful to classless, as I told you. In 96, people realized there is still not enough addresses because these large corporations already had a lot of large blocks. So in 1996, people said, let's invent something for people at home, because more and more people were having PCs, were having internet access, were having small networks. And in 1996, people said, let's write RFC 1918, which is very famous, that states that the 10 network, 10/8, 172.16/12, and 192.168/16 are private internets. That's what they call them. Which means you can use them at home, everybody else can also use them, and they do overlap. So you don't have your own network address, you have an address that anybody else is also using. But this is not on the internet, that's just in your local network. Still, people realized this won't be enough, because internet hosts were getting so many that even if you at home only use private addresses, there will still not be enough. So in 1998, with RFC 2460, IPv6 was introduced. Okay, now you know why we need it, but when will it be here? Well, IPv6 will not be here. It is already here. It is nearly 20 years old now. since RFC 2460 in 1998. And on June 6, 2012, there was World IPv6 Day, and a lot of big corporations activated IPv6 in their networks and in their internet services. So, what are you waiting for? Look at these. You know most of them probably. Google, YouTube, Apple, Wikipedia, Facebook, Akamai, that's hosting most of the images on the internet, Netflix, and a lot of access providers are already using IPv6. So how do you get IPv6 addresses? Well, on top there is ICANN. ICANN coordinates DNS and IP resources on the internet. And ICANN has outsourced operations of the internet protocol to IANA, which means Internet Assigned Numbers Authority. It's a department of the ICANN which is responsible for the allocation of DNS names and IP addresses. And then there are 5 different RIRs, that's Regional Internet Registries. Each one is responsible for a different region. ARIN is responsible for the US, for Canada, the Caribbean. This is the American Registry for Internet Numbers. Then there's RIPE, that's responsible for Europe and Central Asia and the Middle East. There's APNIC, which is responsible for Asia Pacific. There's LACNIC for Latin America and the Caribbean parts of it. And then there's AFRINIC, which is responsible for Africa. So ICANN and IANA are allocating IP blocks to these 5 RIRs. And these RIRs you can be member of. And the members are called LIRs, that's Local Internet Registries. And these are mostly providers and also large enterprises. If you are a member of the RIR, you can request resources from them like BGP AS numbers and also internet addresses. And these providers then allocate IP addresses to the customers, which is probably you or another company or another private customer. This is a nice map indicating where the RIRs are responsible. Let's have a look at some statistics. I always like statistics. Okay, this is the Google index of users connected to Google via IPv6. You can see that this is constantly rising. In 2009, we nearly had 0%, and in 2013, we had about 1%. And now in 2015, we are rising steadily up to 7%, 8%. This is a good thing. IPv4 usage per RIR. I told you about the 5 different regional internet registries. You can see here in blue, which is the allocated /8 address blocks. Remember, 1/8 is about 16 million addresses, and ARIN for North America, Canada, has allocated 83 of these /8 blocks. APNIC has 54, RIPE has 48, AFRINIC has about 13, and reserved from the IETF is 35, which cannot be used. And in red, you can see unadvertised address space, and green is advertised address space. You can see from this chart that a lot of the IP addresses have already been allocated. There are none left, but some of them are not announced on the internet, which means in ARIN region in North America, 30 of the 83 address blocks are not on the internet. So people might be using them in their corporation, but they are not on the internet. And that's a problem because we wouldn't have run out of addresses if everybody was using just that many that they need. Take time and press pause on this video and have a look at this map some more. The IPv4 allocation rate per RIR. You can see that in the beginning of the internet, in the end of the 70s, beginning of the 80s, there was a steady increase up until about 1991. Then it got less. And then from 2000, it rose again. You remember the dot-com bubble. And then in the middle of the 2010s, people were realizing, oh, there will not be any more IPv4 addresses. Let's get as many as we can. So the chart rises again. This is also in colors divided by the different RIRs. IPv4 address rundown model. You can see the RIR pools here with different colors per RIR and how many IPv4/8 blocks they have left. And at the current allocation rate, how long that takes to be depleted. You can see that Afrinic probably has IP addresses up until 2019, while the RIPE NCC, here in light blue, has addresses up until after 2020.